Hi there, and welcome to another episode of Mr. Ed Codes. And in this episode, I'm going to be continuing in my series, Classic Arcade Graphics, by looking at how to make random trees. So I ran into this problem the other day where I needed some random trees in the background of a screensaver that I was making. And I didn't want to upload a bitmap of different trees and put that in there. I actually wanted to use the code to create a random tree. I knew about creating recursive trees. I had actually tried this before, but the problem with recursive trees is they tend to be kind of uniform. So getting them to create like some randomness to where it looks like trees, it's a little bit of a trick, but not too bad. So that's what this program is about. So at the end of this video, you should be able to write the code that produces these trees here. And there's a few things that you can do to make them look different. I'll do something real quick here. I'm going to change that to a 3 and change that to a 3. And let's see what that does. So there's lots of fun you can have with this. You can put sliders in that would control some of these variables, so you can look and see what makes the best trees for you. We're not going to do that in this program, but I just wanted to show you what a small change in some variables can do for this program. So let's start this program. Let's make a new sketch. So I'm just going to clear out that page. We're going to make a new sketch here. And let's blow you up so you guys can see what I'm typing. So a few things first. So I have some room. So when I first made this program, I did the straight recursive tree program that you can find on the coding train, Daniel Schiffman. Just do recursive trees, search in YouTube, and you'll find it's like nearly at the top of the search. So Daniel's code produces a very uniform classic recursive tree. So that's the basic meat of the program that we need. And then when you start doing extra stuff to it, you have to add variables to that. And you may not know what those variables are going to be at the very beginning. So you're not going to know what your global variables necessarily going to be. So as I code this, I'm going through my notes, and I'm going to start at the top and go to the bottom. But if you're actually coding this, figuring out for yourself, you're not going to be able to start with all your global variables. You may not know what all those are going to be to start, unless you plan it out like you're supposed to with the flowcharts and project management and all that. So let's start with our global variables. I could do this a lot faster if I could actually type. So what are these variables? These are all of your global variables that you're going to need for this. The very first one is angle. So the terms I'm going to use, just so we can keep things straight. A limb, and then where limbs go into other limbs is a branching. So that I'm not using branch as a noun and branch as a verb and confusing everybody. So I'm going to refer to branch as a noun as a limb. In the code, I think I have it as a branch, so that's probably not going to help. But just to explain things to you, I'm going to use the word limb. So you have a limb, and at the end of each limb, there are a number of limbs that branch off. In this example, there are 2, but you could have as many limbs as you want branch off, 3, 5, 10, whatever. And it looks best when there's like 2, maybe 3. So what angle does is when you get to the end, if you just go straight off of that, you're not going to know that it's branched. You're not going to know there's a new limb because it's straight off. It's going to look like a fishing pole. So in order to make it actually branch off, you have to change the angle. And that's what this variable here is going to control, the angle at which it goes from a straight line, the limb reaches that branching point, and then it changes direction slightly. It could be left or right. The next variable is move tree. In this example, I print a tree, I move across the screen a little bit, I print another tree, move, print another tree, move. I need a variable to hold that movement. So that's what move tree is. It's going to step through that location. To make my trees look more organic, I need to decide whether there's actually going to be a branch there or not. And if there is no branch, then nothing happens after that. So what could happen is I could end up with just a stump, or I could end up with just one branch that jiggity jags all the way up to the top of the tree. I'm using yes branch to decide whether it's going to be a trunk or just like one kind of branch. And then I'll make multiple passes over on the same tree to produce these different random looking trunks. And then overall you're going to have that random shape. So each tree is actually many trees combined together, composited together to form your single looking full tree. Make pass is a part of that process. So I have the probability that a limb will branch. I have that set at like 20-25%, something like that. So unless I make more than 4 passes, I'm not even going to meet the odds that there's a branch. So I can end up with just a trunk for a tree after 4 passes. So I want to make sure and do so many passes so that I'm assured probabilistically that I'm going to have more than just a trunk. So I took 4 times 4, and that's going to at least give me a couple chances of there being a complete branching line instead of it terminating too soon. The trunk height is going to be a random variable, so that each time it goes back to the trunk to create a new pass, or each time it moves across the screen to create a new tree, there's going to be some variety in the trunk height. I need a variable to hold that. The thickness of each limb as it branches has to diminish, or else it's going to look like boards nailed together, because limbs get smaller as you go up to the top of the tree. So I need a variable to account for that. Each time I make a pass to create part of the tree, I want to offset the trunk just slightly so that the composite will be a thicker trunk at the bottom, and it'll be able to support all of these other branches from the different passes. So now we're ready for setup. The setup is pretty simple. We're going to change this to the window width and height. We need to set our angle. We could have set our angle up here, but in p5.js, until you run setup, it doesn't know what pi is. So if you try to do pi times 0.25 up here, it's going to say, what the hell's pi? You have to do that after setup. I'm setting my angle to 25% of pi, or quarter pi. I could have put quarter pi there, but I just multiplied it times fraction because it's easier to keep track of, and it's a lot easier to type. My background is set to black, and I have to have a starting length for my trunk, which is a random number between 25 and 120. Now in the draw part, I need to set my length. I'm passing length into the function that does the recursion, so I don't really need a global variable for that. I can declare and assign that in draw. It's fine. Okay, so when I make a trunk, or when I fall out of the recursion to make a trunk, it needs to be a certain thickness, and that thickness is always going to be a fraction of the length. So as the length diminishes, that fraction gets smaller, so your limb is always going to be smaller than the one before it if its length goes down. I want my trunks to be kind of brown, so I randomly pick a kind of a darker red or mid-red, dark to mid-red color, and then I set green to well below the minimum of that red value, and that's going to produce kind of an orangey brown color. If I want it to be more brown, then I'd add a little bit of blue, but not much, because then it starts getting purple. Now this is a really weird way of doing this, but it's what I worked out and it works okay. So I'm picking a random number between 0 and 4, and then I'm going to make an integer out of whatever that is. So it would be a number between 0 and 3.99. So the integer would be 3 at the most, 0 at the least. So that's a 1 in 4 chance of there being a branch there, 25%. So if I make my passes 4 times that, then I'm assured that at least there's going to be a nice branching system on the tree, even if it's a little skinny and sparse. I want to increment my pass because I'm about to make a tree, or at least one. I'm making a new tree, so I want to increment the passes so that I know to keep track, and when I get to the end of the number of passes, then I'm going to go on to my next tree. Each pass on the tree is going to be, the trunk is going to be offset slightly so that the composite is a little thicker trunk, and then the limbs don't branch off straight up the trunk. It's kind of offset a little bit. It makes sense when you look at it visually. So if once you finish this program, if you want to mess around with that, you can see the difference that it makes. So the offset is going to be half of the thickness value. So I'm never going to be off of that trunk the entire width. So you're not going to have two trunks really close together. It's going to be one trunk on top of the other to make it look like one thicker trunk. So I want to check and see if I'm done making the passes, if I've made enough passes on this tree. If I have, then I'm going to move my tree across the screen a good width, which would be about the diameter of the canopy of that tree. I guessed it was around 120. You might have to just fudge around with that and see which one looks best on what you're trying to draw. I have to set my make pass value, my incrementer, back down to 0 so I can start over. And then I want to check and see if I'm out of bounds, if I'm trying to make a tree off the screen. And if I am, then I want to clear the screen and then go back to the beginning. So right here, this is going to be a little weird. You don't have to include this, but if you want to see the output, if you don't want it to be erased right away, you could put wait in here. That would stall the program until you press the space bar. I'm putting a loop, and then I'm going to have that loop do something that takes a lot of processing time. Probably not the best way to do this. I know it isn't. So what's this doing? When I get to the edge of the screen, once I've printed, I've printed my trees, I'm over here, I'm getting ready to jump back here. Well, if I didn't have this in here, as soon as it got over here, clears the screen and it's back over here. I want to see the output for a little bit. So what I do is I just tie up the processor with this loop, printing nothing 20,000 times, and then that should allow me to see the output before it restarts. This is just temporary so you guys can see what's happening. Ultimately, what you would do is you would print this to a graphics page, and then you would use that graphics page, and you wouldn't have to keep reprinting your trees. Because here's what happens. You create a random tree. Now you want to use that random tree in your program somewhere. Well, when you go to make that random tree again, guess what? It's random, so it's not going to look the same. You want your trees to stay the same, so you have to print them once and then keep that image, not erase it or mess with it. And then if you want new trees, you just print those trees again. But if you want to keep the trees that you've made, you either have to keep track of all the random values and then step through that process exactly the same way each time you want to create a tree, which is completely impractical, or you can create a graphic page of that tree. You can even store it in a bitmap and then pull that up and do it that way. But what you can't do is use these trees over and over again. Once you've erased them, they're gone. You've made them, you can keep them, but once you've cleared the screen, that's it for that tree. So in order to see the tree's output, I have this here. But if you wanted to really do it right, you would print it to a graphics page and then just use that graphics page. And then you could clear your regular graphics page the way you want without having to worry about erasing your trees and having to redraw them again. So that's what that's about. I know it's weird, probably not the best way to do things, but it was just temporary. I could have used a wait there, but I kind of wanted to show how old school we used to slow down programs. You would use some little chunk of code that would tie up the processor and slow things down. Usually the processors work so slow you never had to worry about slowing things down. In fact, you had to worry about getting things to speed up. So it was rare to use that, but there was an occasion where you'd want to wait for a while. So we're down here. We're past the width of the screen. We've waited to see the output. We're going to clear the background and then start over. That's if necessary. If we haven't met any of those conditions, then we're falling through that and we're going to be doing this stuff here. We're translating. We're setting our position to the bottom of the screen to wherever we're printing a tree at, offset by that slight amount so that we get a composite. And we're going to print that near the bottom of the screen, 20% from the bottom, or 80% of the height. And I think I can take this out of here now. So now we're ready to, once we've translated the origin to wherever we want our tree to start, now we're ready to go into the function that's going to do the recursion. It's going to create the limbs. We're going to send into that function the starting length value, which is that random number between 20 and 120 or whatever it is. And then we're going to do our branching. So we create a function called branch, and we're going to pass into branch that value length, and then we're going to use that to figure out how we need to make our limbs. So up here I'm starting with my trunk. So I'm translating at the bottom of my trunk. Then when I go into the recursion to make the branches, the limbs off of that trunk, I need to move that origin to the end of the trunk, or to the end of the limb, whatever the case may be. So that's what I'm doing here. My origin is right here, and then this is the end of my trunk, or the end of my branch, from which, or the end of my limb from which branching will occur. So I've drawn my trunk. Now I'm translating to the end of my trunk or my limb. I'm going to check and see if that limb is long enough to do a recursion on. And if it is, then I'm going to do all of that business. So I have two pushes and pops. Here's two containers that's going to hold any transformations that I make, so that when I fall out of this transformation, I'm going to go back to this origin. So if I have to make any branches off of the end, it's going to know where I need to be to do those. And then if I have to go back to make my other branch, it's going to know how to do that, just by keeping things separate in this push and pop. If you follow it line by line and draw things out and flowchart it, it makes perfect sense. But conceptually, this may be a really challenging thing to understand, because you have like a global translate, and then you have movements or translations that occur in containers, and then when you fall out of that container, it goes back to the global translate value, and then you can change that to be whatever the container value is, so that it always ends up going back to where it needs to be. That probably made no sense. I tried. The limb is long enough to branch from. Let's see if we actually need to branch from there. So we're going to use our variable yes branch, and if we meet a certain threshold, then it is going to produce that branch. I think that's where that needs to be. Otherwise, it's just going to skip over it. It's not going to produce the branch. It's going to reduce the length that we're working with, and it's going to go back through and see if we have a branch there again. Well, we don't, so it's just going to reduce the length, and it's going to keep doing that until it's done, and then we'll go back up and make another pass at the tree. So inside push and pop, we're going to change the stroke color to that brown. You can copy the color from up above if you want to make things easier. It's the same stroke we have up here, right there. Just copy that, paste it down here. Once we have our stroke, we need our stroke weight, which is going to be a fraction of however long the limb is. So as the limb's getting longer, the value of that fraction is getting smaller. So there's always proportional. So we want to rotate our limb by a fraction of pi, and we're going to do it negative or positive randomly. So it can branch leftwardly or rightwardly. And we have two branches that come off of the end of each, two limbs that come off of the end of each limb. And that's what this is one branch, this is the other branch. So I'm going to use a negative quarter pi. I'm going to multiply that times 1, or a fraction of 1 actually. And then just duplicate that. Come on, get your stuff together. Here we go. There we go. So I have negative quarter pi times a fraction, and then quarter pi times a fraction. I'm picking a random number between all of that. And then I'm going to rotate by that value. So I'm calling the recursion function inside the function, the branching function inside the function. That's what makes it recursive. And before I do that, I need to reduce the size of that branch by so much. And it's going to be 70 to 80% of what it was before. It's going to shrink, right? Now all the changes and transformations have happened. So when I go back up to here, it's going to make the line the way that it needs to. And I think what we can do here is just copy this part and just do it again. If I wanted 3 limbs to branch off of a limb, then I would just add 1 more of these. If I wanted 4, I'd add 1 more. If I wanted a dozen, I'd put in a loop and just loop through it. But 2 branches is enough. You get more than that, it starts to look like a witch's broom. So I'm at the end of that pop. I'm at the end of the condition here. So I asked the question up here, are we long enough, or this is the yes branch. Okay, so if we are branching, we're doing our branching, right? And if we are long enough to branch, then we're going to at least go through that possibility. But what if we're not long enough to branch? What if the length is too short? That's where we're going to handle that here. So we're going to put an else on the end of that if condition. So if it's less than the minimum size, which is 10, we can have that be 5 or 20 or whatever you want it to be, just so long as it's smaller than the initial starting length, or else you're not going to get anything. So if it is too short to do anything with, we're going to end the recursion, and we're going to end each recursion, which is going to be the end of a branching system. We're going to end it with some leaves or a piece of fruit. So how are we going to do that? Well, we have to encapsulate those transformations. we're going to use an ellipse with no stroke. I guess I need an R in there. I'm like, why isn't that blue? So this is the condition if there is fruit. Maybe. No. Nope, I'm missing something here. I need a condition. So I need a variable, actually. Let's do that. So let me create, let me declare and assign the variable flower inside this function. So I'm only going to use this variable in that function, and it doesn't need to be a function variable. It could be if you wanted it to. It's going to be a random number between 0 and 1. And then if it's 10% or less, so 10% or less of the time, it's going to be a flower or a fruit. And then otherwise it's going to be just a green leaf. Does that make sense? So if it's meets this condition, we're going to make it red like a flower. And then if it's not, we're going to make it green like a leaf. And I want it to be different shades of green. Hard set this to 75. A little bit of purple, or a little bit of blue. And some transparency, so not full opacity. So once I figured out what color it's going to be, I need to make that leaf object, or fruit, or flower, or whatever. And I'm already translated to the end of that branching system, so I just have to drop it at 0, 0, and it'll be where it needs to be. And I want it to be a random width or height, so they can be flat or leaf shaped. They're not always going to be perfectly round. And then the very last thing we need to do is reset, because we're at the end of our branching system, we need to reset the starting length to whatever we want it to be. And we need to retranslate or reset our translation back to that must have been a leftover from when I was hard coding everything. When I first did this program, I created one tree in the center of the screen. And then I was like, well, I want to make many trees go across the screen. So that's probably some kind of legacy of that change. Height times 0.8%. Or 80%, I should say. So I'm translating back to wherever the tree needs to be at, and its height is 80% down the screen. And I want to reset its rotation back to 0 in case it's not. I don't want a trunk to be like 45 degrees and like it's falling over, which would be kind of cool to do occasionally if you were making like a tree line out in the wilderness. All right, with any luck, cross our fingers, maybe this should work. And let me move this over here so you can see if it's working or not. And it is working. So if you've typed this code in, as I've shown you here, you should have the same results. Now, like I said, you can change 1 decimal and completely affect the output. So if you've made any mistakes along the way, it may not look exactly like this. So that's what I had to do when I started noticing, well, why does the trees look like they've been eaten by a giraffe compared to looking really full? And it could be the difference right here between 0.2 and 0.7. So what is the whole point of making these trees? So let me load a program for you. So this is a a graveyard, a cemetery. What I was doing was I was using the waves, the water waves from a previous video. You can find that here. I'm using those water waves to create fog. So I created the fog, and then I needed some objects behind the fog to see, so I could see the fog better, right? So I created these headstones just to test this concept of making fog. But it looked so cool, I was like, oh, I can just take this up a notch. So I made random headstones. I made a horizon, so it looks like there's a volume there. And then I was like, oh, I need trees. I need some spooky trees, or a spooky tree. And I knew that I could make recursive trees. I just had to figure out how to make them look like a tree and not like a fan. So randomize them a little bit. So that's where this exercise came out of. So once I had the tree making program, like I said before, I just printed a bunch of trees to a graphics page, and then I print that graphics page first, and then I do my animations over the top of it so that I can clear the animations in the regular graphics page without erasing my trees. Then this is tied to the clock, so every 30 seconds it creates new trees, repositions the moon, new tombstone layout, and you'll notice here is a little creep, 2 eyes that blink, and they show up randomly. So every time it refreshes the scene, these eyes are going to be in a different place. So it was kind of neat as a screensaver whenever it would refresh to try and find the blinking eyes. Super creepy. So I want to have more creeps in this. I want to have a skeleton hand that slowly reaches up out of the grave and then goes back in over like the course of a minute. Maybe a ghost flies out of the grave and over the top of the screen. A bat might fly across, or a cat. And maybe add some random noises like a wolf and some crickets, a frog, maybe a screeching cat, stuff like that, an owl. And if you'll notice too, the moon, as it's closer to the horizon, is larger, and then as it's near the top, it's smaller. And then I created a star field in the back too. So there's lots of stuff here. I can run through this program. You can see that it got pretty involved. Creating the tombstones, creating the branching, the star field is a class object. The tombstones, pretty easy function for making tombstones. So yeah, I had this plan, I had this need for a tree, and I went and researched to see, can anybody show me how to make a random tree? And not really. So I figured it out myself, created this little demonstration so you guys could use this in your code and you don't have to reinvent the wheel. So I hope you have enjoyed this video. I hope you've learned something and are able to use this code in your own programming. That's it for this one. As always, I appreciate you watching and leaving the feedback if you leave any. And I guess that's it. Until next time, as always, take care.